To get started, the first thing we need to do is understand architecturally how the tools come together when we're doing our development. Now, as a frame of reference, let's first look at what tools basically are laid out like when we're dealing with development in the Microsoft .NET experience. Now, as a .NET developer, more than likely your home experience is Microsoft's Visual Studio, right? It's kind of the universe of our development. And of course, we have our app. And when we're working against our app and we're doing our development, a good deal of the time, the app that you're working on and Visual Studio are running on the same machine, right? It's running on your desktop or your laptop, right? Whether that's a desktop application or an ASP.NET application, very often you're working locally. And even if the application is running off on another server, it's like an ASP.NET server, the reality is it's still a very homogeneous environment in the sense that the environment that the app runs on is very much like the environment that you work in, right? Windows. So when you do your development, Visual Studio is just basically just connecting up to the app, and anything you do, debugging, monitoring the app, looking at logs, anything you do is probably happening from Visual Studio. Yeah, there might be some proxy processes that kick in to help some things out, or maybe occasionally you'll use another tool like perfmon or something to see what's going on. But the reality is Visual Studio is the heart of your experience. As we look at the Android development environment, initially it'll look very similar. Right, we start out using Eclipse. Right, Eclipse is our IDE, so it's very much parallel to using Visual Studio. And of course, we're going to work on an app. But a couple things start to get different very quickly. Right? One thing is that, well, your IDE is running on your desktop or laptop. It's probably, in our case, it's a Windows desktop or laptop. It could be Linux or Mac, but for most of it's probably Windows. And the app is overrunning on either a device or a virtual device. Right, now those are physically separate environments, but they're also just architecturally very different environments, right? Android is a Linux-based platform, right? It's a Unix-based platform. And it's also optimized to run on a small device. So whether it's a physical device or a virtual device, it's a very different environment. And they are physically separated, right? In the case of a real device, you're connected by a USB cord. In a virtual device, you're connected by some software simulation of that. But it's very, very disconnected. So the experience of doing the development has to change somewhat. Also, it's important to remember that Android is designed in such a way to not be tied to any one development environment. Eclipse is kind of the preferred way to do it, but people use lots of different editors to do this stuff, lots of different environments, lots of different operating systems. I mean, you literally could work in Notepad and the DOS command line, right, or the Windows command line to do all your development. So the tools are really built around this flexibility and not being tied to a single development environment. So that idea changes the way things come together. So what happens now is that because we're talking about a physically separated environment, there's something called the Android Debug Bridge, or better known as ADB. Right? In the ADB, there's an ADB daemon running on the device. Right? Daemon is just a name for a background process. Right? And then on your desktop, you're going to have an ADB server. It's a server process, and it's responsible for managing the communication between the devices. So pretty much everything we do from a development standpoint is walking through that bridge with the ADB server on your desktop over to the ADB daemon on the device. So now what happens is when you want to do something like debug the application, well, the debug interaction with the processor, with the app, happens on the device from the ADB daemon. That communicates through the pipeline and connects you up to Eclipse. Now, the actual debugging, the actual Java-based debugging, uses a standard protocol called the Java Debug Wire Protocol. It's a standard mechanism for debugging Java apps, and that allows Eclipse to easily work with that for debugging. But very quickly, the work we're doing needs to be more sophisticated than just simple debugging. Right? There's other things we want to think about. Something that's very important when doing mobile development is having a logging system, right? The ability to write messages out to see what's going on. In Android, that's called the logcat system. Right? And so logcat is just a subsystem that runs there on the device, keeps track of log information about what's happening with the device itself, and applications can write information out there. So your app would write information to the logcat. If you want to see that, you go through the ADB subsystem, and that allows you to have a logcat window inside of Eclipse that will let you read that logging information. We'll talk about a bunch about logging shortly, because understanding how to use that environment is really important. Also, the ADB daemon running on the device or the emulator connects in closely with the system. and so that it actually can interact with the operating system itself, and in the case of the virtual devices, can even interact with the virtual device's behavior and environment. So the ADB daemon is tied in very deeply on the device side. So what happens is a utility we call DDMS that allows us to do things like monitor your application and what's going on there, but also you can issue commands into the operating system and into the emulators to control behavior and interact very closely with the system itself. Now, most of the work we do occurs through Eclipse or these embedded environments in Eclipse like Logcat and DDMS. But it turns out that the ADB system also has a command line utility where you can open up a Windows command platform, or Windows command line, and issue commands from that to interact with the ADB system. So you see that it's a much more sophisticated system going on here to bring it together. Now, a key thing to think about, though, is that this is not intended to be intimidating. It's just so you have an understanding of what's going on. You'll see that once we go through the tools, you'll see a lot of the complexity starts to get hidden away for us, but it's really good to have a good picture of what's going on so you have a sense of how the tools are working.